Probando. Well, welcome here to this meetup in Adevinta. I am happy to see you all here because the weather is really, really bad, but all of you came here, so I hope you will have a good time. You will learn something, and later we will be able to eat pizza and drink some soft drinks. So hopefully we will have a good time together. And so thank you for coming here to Adevinta, to this meetup. And first of all, I want to do a quick introduction about Adevinta, and then I will give pass to my colleagues. So let me one moment. Adevinta, it's a global company, and it's located in many countries around the world. For example, in North America, in South America, in Europe, and it owns many brands, many marketplaces, as you can see there. For example, in Europe, Adevinta is located here in Spain, of course, in Italy, in Germany, in Ireland, and many other countries, and with many and different brands, as you can see also there. And here in Spain, the marketplaces or brands that Adevinta owns are Fotocasa, Milanuncios, Infojobs, Habitaclia, Cochesnet, Motosnet, and I hope you all already know about them, and also I hope you use them a lot. So, but well, about the numbers in Adevinta, you can see there some of the numbers. For example, we have 17 millions of unique users per month, and also more than 50,000 new ads per day. So quite really big numbers. And well, as you can see, seeing also the numbers, Adevinta is doing all right. So good for that, good for Adevinta. And well, about people here working, for example, here in Barcelona, but also in different locations like Paris, Berlin, Amsterdam. We have people working from many and different countries and nationalities, and we keep hiring new talent, as you can see there. So if someday you join us, you will be able to work with people from different nationalities and with different skills, and for sure we will be having fun together. And just quickly also about me, I am Gustavo Martin, and I 5 years ago I joined here a data platform team, but before that I was a backend and front-end engineer, a full stack architect. And now here in this data platform team, I am working as a data engineer. I say data platform engineer because we need to create applications, Spark applications, ETLs, ELTs, or whatever. But we need to create also infrastructure. So in this data platform team, you need to have skills for like the typical data engineer, but you need also to know about infrastructure. And that's why I say I am a data platform engineer. And if someday you want to reach me, you have the links. So, and that's it. I am going to pass the microphone to my colleague.
Thank you. Do you hear me? Yeah, you hear me. I'm going to change the slides. Yeah, intro. Let's give applause to Gustavo. Actually, he wrote us like 1 month ago, and he was like, "Why don't we can we do a meetup about Spark 3.5?" And it's like, okay, let's do it. And somehow it's like we got organized something, and we're really happy that Gustavo was like almost did everything in the organization. So I'm going to give another applause to Gustavo because been so nice. We are Spark Barcelona. I will do like the introduction on the meetup. Yes, the slides. We are a meetup that we talk about Apache Spark. I'm sure that everyone will know about this technology, and if you don't, you'll learn something today. Our main goal here is to share knowledge, and usually what we do is do this format of events, but also networking. We think that connecting to each other, it's really important for this industry. So that's why after the events, normally we do like some beers or something, and it's a space for chatting and keep the conversation going on. It's the first time I put this link, but if you are not in the Slack channel, you can join by going here. If it doesn't work, just tell me and we'll figure it out, because it's the first time I put it here. We are, how much? 3,000 people joined since the beginning of the meetup. That it was in 2014. It's been quite a 9 years. The pandemic was quite difficult for every meetup, but with the community, it's always nice to keep going on these kind of things, and I'm so happy that so many people joined today. Could you raise your hand if it's your first time in the meetup? 1, 2, 3, 4. Wow, that's a lot. And the ones that, and can you raise your hand if you ever used Spark? Yes. Okay, nice. A lot of people. That interesting conversation. We'll have interesting conversations. So if anyone can, I don't know, share whatever, like an experience that he had with Spark, or a problem or doubt or anything, that is a place where you could share your experience if you want. So like Gustavo, that just text us a message. If you text us, we maybe it's like a channel that we can organize something for the community. Today we will talk about lots of topics: Spark 3.5, Spark Connect with Gustavo, that will give us the presentations, and then liquid positioning and uniform, that Paul and Paola will give us a glimpse of what is that. Thanks again to Adevinta for hosting us, and let's start with the content. That's good. Not applause. So we start with Gustavo. No, this one. Sorry. Gustavo, I don't know if you want to be interrupted or.
Well, if there are questions, it's not a problem.
Okay.
If someone has a question,
Somebody want have a question?
if someone has a question and I can answer in the middle of my talk, you can raise your hand and I will try to answer your question. And if not, we can do it later again while eating pizza or drinking soft drinks or whatever later in the canteen. So
You got the pointer here?
yes. So here we wanted to explain new features that are coming in Spark, in the latest Spark version, in the latest release. And here I have a short amount of points that I believe are interesting for you all. But if you follow some of these links, you will see also more interesting things in the latest release. The first point that you can see there is Spark Connect. Few moments I will be talking much deeply about Spark Connect, but it's something really interesting that appears in the Spark 3.4 version. It was released one version before, but also in this latest version in 3.5, many improvements have arrived to Spark Connect. So that's why I thought it would be interesting also to talk about Spark Connect in this latest version. Related to Spark SQL, something interesting that we can see now in Spark 3.5, it is related to identifiers and the support for named arguments. If some of you are coming from if some of you have been working in the backend, if you have been working as backend developers, probably you already know about the prepared statements that you should be using in order to run queries in your database. And in Spark SQL, we didn't have prepared statements. So what happened without prepared statements? What you can have is something like the query that you are seeing, the first query that you are seeing above, where you are doing a select from a table, but this table is coming from, the name of this table is coming from a variable. But this, before having identifiers, for example, or named arguments, if you wanted to create a dynamic query with a Spark SQL, you will be doing this query with a string. You will be doing a concatenation there between your select and the table name that is coming from a variable. But the problem here is that this variable could be, the value for this variable could be coming from data that is created by an external user. So in that first query above, that you can see, you will be having a concatenation between something that you are not controlling and your query, your select statement. And that's something that you don't want to do. You don't want to work with strings in this way, because what it could happen is that you were expecting there a table name, but perhaps the user is inserting there a filter or whatever. So that's something that we call SQL injection, because some external system or some external person is doing something with your query and is modifying the way that this query behaves. And this typically happens because you are creating your dynamic query, you doing a concatenation of strings. With identifiers, now what we have is something like a prepared statement, where the engine, Spark, will be replacing this variable like an argument. And now you don't need to rely on a concatenation of strings. Now is the engine, the Spark engine, the one that is replacing only this variable, this identifier. So with using this identifier, you will be avoiding the SQL injection that could be happening. But also we have now in Spark SQL, and again I will be talking about the prepared statements, we have named arguments. And now again, you can pass values to your query using named arguments instead of doing a concatenation of strings, for example. So in this way, now with Spark SQL, having identifiers and named arguments, we can avoid the SQL injection that since many years ago, backend developers were already avoiding using prepared statements. But this is something that in the that we as data engineers we were not used to dealing with, because it is something that it was more typically suffered by people from the backend. But now, because it's really easy to run a Spark SQL, there are more chances of using Spark SQL directly from backend applications or front-end applications that are running against an engine, and in this case, the engine is Spark SQL. Also, things about Spark that came with this latest release are related to Python. with Python, you know probably that the user-defined functions are typically slow, and it's something that we always try to improve as much as possible the performance of these user-defined functions. And now with the latest release of Spark with Python, we can, and the UDFs, we can use something called Python Arrow. Perhaps here people working with Pandas and Spark know more about Python, about this library Arrow, because typically when you want to transform data from Pandas to Spark, that transformation had a slow performance. But with Arrow, because the way that this library is implemented, the performance of this transformation is better than before. And this increase of performance is also being applied now in the user-defined function that probably if you have used you have been using Spark with Python, probably a few times you had to implement by yourself these user-defined functions. So now you can use Python Arrow also with user-defined functions, and the performance of these UDFs it is much better than in other Spark versions. And also I wanted to add here a point about testing, because in the backend developers are more used to testing their applications. Here there is something that I see a lot, and is that many data engineers are creating applications, Spark applications in this case, but other applications happens also. And these applications are not tested, because here we are used to not many people. That's something also that many times is forgotten, but it's also talking about data quality, right? But many times we don't try to test also if the business logic of our applications is implemented right or wrong before deploying this application in our production environments. And for doing that, it's important to test your applications. If you are not testing your applications, you should be doing. But this is a subject, a complicated subject, and perhaps it should be treated in a different meetup, in a specific meetup only for testing Spark applications. But because the Spark developers now that testing your applications is important, they keep improving the libraries related to this testing. And in this case, as you can see there, they're improved in this latest release, these libraries for doing asserts. And now with these libraries, for example, they are giving us more information about if a test is not passing, why this test is not passing, what condition is failing. And they have improved also these libraries in order for us to be able to our tests. And testing your application is something that you all should be doing. And well, as I said, I was going to talk more deeply about Spark Connect, and that's what I am going to do. And after that, if you have questions or something for me, I can answer some questions. But if not, later in the canteen we can talk and explain more about Spark. So now I go to explain Spark Connect, and that will be the last thing that I will be doing. So let me explain Spark Connect. But first of all, I wanted to show you here this diagram. This is the typical Spark architecture with the driver, with the cluster, and with the workers. Here you see the typical diagram of a Spark application. And what happens here? If you want to run this Spark application from a different application, imagine it would be perhaps a bit strange to do that. But what happens if you want to run an Spark application from a microservice? It is strange, but what if I want to do that? What if I want to run a Spark transformation from a microservice? In this microservice, I already have my libraries, and perhaps those libraries are implemented with Java or Kotlin. And now, because I want to run this Spark transformation, I need to add to my microservice all the libraries required by Spark. But not only the libraries, but I need to also add the infrastructure or hardware that will allow me to run Spark with the workers or with the drivers. Many times we will be having conflicts. For example, perhaps you don't know about that, but at the beginning, Spark was using Akka, a framework for asynchronous communication, and it had to be removed because there were problems between the Akka libraries and the Spark libraries. So if you have an application using Akka libraries, you will not be able to run from this application Spark because there are conflicts. So we need somehow a way for doing an isolation between our applications. For example, in this case, I was saying a microservice, but could be any other application, and Spark. And for doing that, in the past, well, and even now, there was and there is something called Apache Libby. Here, for example, at Adevinta, Spain, until not many months ago, we were using Apache Libby. For Apache Libby is doing this isolation between your application and Spark. In your left, you can see something that says client. The client could be your application, for example, a microservice or whatever you have there. Between the client and the cluster with Spark, there is a REST server. That's Apache Libby. And to the right, you have at the end your Spark application running in its own cluster. So what we have now is with Apache Libby is a REST server. This server is exposing an HTTP endpoint. And now our applications, for example, this microservice or whatever, can run Spark applications through Apache Libby in a way that is isolated from Apache Spark. So in this way, we don't have any more problems between libraries that are in Spark and in our applications. There are no conflicts anymore. And also, if you want to change for whatever reason your Spark application, it can be done without affecting your application that is located in the client side. And this is something that, for example, here we were doing at Adevinta Spain until not many months ago. But the problem is that this is not an standard. For example, Apache Libby, I believe right now it is losing traction. Not many developers are doing commits there, and perhaps someday Apache Libby will disappear. I am not sure. And also the problem is also that it's not a standard. So because of those two things, for example, if you want to use Apache Libby with Databricks, that's something that you will not have out of the box because it is not an standard. And now what we have, instead of this Apache Libby, this separation, we have this new thing that is called Spark Connect. Spark Connect was released in Spark 3.4, but in the latest release, in the Spark 3.5, there were many improvements, and that's why we are speaking about it here. And again, as you can see here, we have something similar to what we had with Apache Libby. We have the client to your left. In this case, you can see their applications. For example, PyCharm. you could be running Spark Connect from PyCharm. In the middle, we have the Spark Connect server, exposing also some API. And to your right, you can see the Spark application running in its own cluster, for example. So it's more or less similar to the diagram that you were seeing before with Apache LB. But here there are some differences. For example, this API, it is implemented not with HTTP endpoints, but with remote procedure calls. And what is doing here, we have, for example, a small library, a small Spark Connect library that you will need to add to your application, for example, to PyCharm. And this library, what it's doing is is sending unresolved query plans to the Spark Connect. Spark Connect sends these unresolved query plans to Spark, to the Spark application. The query plans are resolved, and the results are sent back to your application through the Spark Connect server by means of these remote procedure calls that are implemented there. So again, now there is a complete isolation between Spark, between your application, for example, PyCharm. Now you can work with the Spark applications from PyCharm without having to install a Spark, or you don't need to configure anymore a Spark environment in your computer in order to run a Spark from PyCharm. You can do it with this small library, with this small Spark Connect library, but you will need for sure in the cloud or somewhere a Spark Connect server running for you. But the good thing is that you don't need to anymore to have the whole Spark environment, for example, in PyCharm, in order to run your test in your computer. After this, I wanted to show you, well, here in this slide, you can see also links to the documentation about Spark Connect, and for the two releases, the 3.4 and the latest, the 3.5. And more or less, you can see there what I was explaining about the remote procedure calls that are being implemented there. I wanted to show you a real example using Spark Connect, but because we don't have too much time, and also typically when I do these kind of things, everything fails. So what I did was to put here in the slides the steps that you need to follow in order to use a Spark Connect server in your computer or in a remote machine, in the cloud, whatever. So you can also follow the instructions in the Spark web page, because they are really clear. But the first step, you need to download for sure Spark from the web page, and you can uncompress the package, and inside this package there is a script, the Spark Connect server script, that you can run out of the box. And once you run this Spark Connect script, what you will be having is a Spark application running there for you. And you can see there the Spark UI. It's a Spark application running there, and it is waiting for someone to run Spark jobs there. And how you can run Spark jobs in this Spark Spark application? Well, first of all, typically you will be doing this thing in the cloud, for example, in a server, in a remote machine running in the cloud, or in a remote server. So you have already the Spark UI, the Spark application running there, waiting for something, for the Spark client. And for using your Spark client, you need only the library. It's a small library for running Spark against the Spark Connect server. And you can start your session. You will be doing the same that you will be doing with your typical Spark application. The only thing that is different is that now we are using this remote function that you can see there. And in this case, because these screenshots were taken from my machine, you can see that I was running a Spark Connect server in my local host. But typically there you will be having the link to a server running in the cloud, for example. And as you can see there, we are running a transformation, or in this case, just the range function in Spark. And what we can see is that now you are doing running this Spark function in your machine, but it will be running not in a Spark process in the application that is running this range function, but it will be running the Spark job. It will be running in the Spark server. So in this way, this Spark server could be in the cloud, for example. Your application could be in your local machine, but you didn't need to have the whole Spark environment in your computer. You can do it without avoiding all the problems of installing Spark in your computer. And that's it. As easy as that. If you have questions, you can answer. Perhaps I can answer some questions now, but if not, we can do it later. So if there are no more questions. Sorry.
Okay.
Yes.
So with the Spark Connect, so in the Spark you got your driver code and your executor's code. The Spark Connect, when you run your code from, your machine, your PyCharm or whatever your local application.
Yes.
The driver, it's in your machine, or it sends this.
No, you don't even have the driver there. The driver is in the remote machine.
Remote.
The only thing that you have is like this small library that is sending your commands, your instructions to the Spark Connect server by means of these remote procedure calls.
Okay.
But you don't the driver is not in your machine. Everything is in the remote remote machine.
So all the code needs to be serializable, otherwise it won't be able to send it.
The code, yes, indeed, it is done by the Spark Connect client. It is sending your actions, your Spark actions to Spark.
Okay. Nice, thank you.
Okay. My question is more about how do you use the endpoint, and how do you secure the endpoints? Do you use Spark Connect now in Adevinta? Do you have any way to secure the endpoints, or how do you do it?
Here we are not using right now, at least at Adevinta Spain, we are not using Spark Connect directly. We are using something else, but is based on Spark Connect and is Databricks. Databricks, the latest runtimes are using Spark Connect underneath. We are using tokens, but if I am not wrong, also in the open source version, they are thinking about, I don't know if in this release, but in next releases, they are thinking about adding authorization or authentication to this Spark Connect server. But here at Adevinta Spain, at least we are right now, sorry, because things will be changing or change in the future. But right now we are using Spark Connect, or the way that Spark Connect is implementing in the latest runtimes of Databricks, and it is by means of tokens. But in the open source version, they will be done also authorization and authentication to Spark Connect.
Okay, thank you.
Other question?
Any other? No. Yes.
My question is, in your diagram, I saw the Go logo. So I know that there is a Go API to use Spark Connect, but what does this exactly mean? That you can use normal Spark code from Go, or which is the interaction here for Go?
Yes, indeed. Here, this example is implemented in Scala, but you could be doing something like this with Go. With this Go library, you see here the Spark session implemented with Go, with Scala, but you can do the same with the Go library, with the Go implementation. So here in this case is Scala, but in your case, if you have Go, you could be doing the same.
So this could theoretically mean that you can write a full ETL in Go.
I don't know if a full ETL, I guess so, but I didn't test it. But yes, I guess so. And also the good thing is that you have a microservice or an application in Go, you can run a Spark from there without having, it will be impossible to run a Spark in Go because Spark is not implemented with Go in Go. So for you, it would be impossible to do that. But now with the Spark, the Spark library, the Spark Connect library for Go, you could do it. But I didn't test it. It's a shame, but I guess you could do it.
Thank you.
Yes.
Hey, thanks for sharing this. It's super helpful and insightful. So, like, I know you mentioned you've not tested it too much. I was just wondering, like, since there's maybe a network in between, imagine you're running from local, you're connecting to a remote server. Like, do you have an idea, maybe from a performance standpoint, you want to load, bring back sets of a batch of data or something?
Well, the problem with the performance, it would be if you are retrieving a lot of data.
Yes.
But with a Spark, it is something that is strange, but this is not like a typical database. With a Spark, what you want to do is to work with a huge amount of data, right? But you and you want to do some transformation, right? And this transformation, typically, you don't want to retrieve the result of this transformation. What you want to do is to write the result of this transformation in another place in your database. It is not like in the microservice world, in the backend world, where you are retrieving data. Here, you are doing the transformation and writing the transformation, for example, in the same database where you have already the data. And later, you have there the transformation, the result of the transformation, and perhaps a diagram, a dashboard. You will be connecting to a dashboard to that result of your transformation. But you are not bringing to your client, to your application, the result of the transformation. It is not the way that this works, because many times you are working with hundreds of gigabytes, and the result, it could be also hundreds of gigabytes. And you don't want to return that result to your application. You want to write the result in the database. So to your client, you will not have data coming to your client. Everything is done here in the Spark side, in this place. Here to your right, everything is done to your right. The only thing that you will be retrieving from the Spark application is if the transformation went all right or not. It is the only thing that you will be having, because everything, all the movement of this data is done in the Spark to your right, in the Spark application. But again, because here Spark is intended to be used when you have a lot of data, many hundreds of gigabytes of data, and it doesn't make sense to return this data to your application. I don't know if that answered your question.
Yeah, I guess like the use case, it's better to limit the use case in places where you want to submit the process and maybe something will process and move, but maybe return some sort of signal or control saying it is done or not, or status. That's what you're suggesting.
Yes, well, Spark will be telling you if the Spark job ended with success or not.
Or not.
And later you can connect here to your database, a dashboard or whatever.
It makes sense. I think it makes sense. Just like, sometimes when you work in Databricks, I've seen teams like you exploring data, maybe connect to a storage container, you explore, you do some small transformation, you check, that sort of workflow. Maybe it's not suitable for this one. It's more like submit.
Yes, and the checks, and perhaps I don't know what kind of checks. Well, it could be also data quality, as we were saying before. But also the data quality could be checked in the Spark side.
Yeah. Okay. Thank you. That's useful. It's thoughtful about the architecture before even.
Yes, I know you. I know you. Great.
Thank you.
You are welcome.
A big applause for Gustavo. And now we'll move on to, I think, Paul, yeah? Yes. Paul. Nice. Micro, you got your mic here? You got your one. You got your slide.
Let's see. You hear me? Yeah,
Yes.
you hear me now. Thanks. Hello, good afternoon. And today we're talking about liquid clustering or liquid partitioning, who knows. So the thing is that when I'm talking with people around, sometimes I hear liquid clustering, liquid partitioning, but I would like that by the end of this talk, you all have a clear idea of if it is liquid clustering or liquid partitioning. And well, I'm telling you already, it's liquid clustering. So what is liquid clustering? Liquid clustering comes from the issue that there is no good way to organize the data when you have big data using partitioning, which is what like everyone has been doing for the last 10 years. Because in the partitioning schema, you say, hey, let's organize the data by time. And then you say, okay, by time, how do I do? I split the time by day, by month. How do we approach this? Or location, like cities? Do we split the data set by cities or so on and so forth? But there is no good way to do that. Let's see if it works. Yes, it works. And the reason here is basically you end up selecting one of them, but you cannot choose all of them when you partition the data, because then you end up with a lot of small files. And a lot of small files are super slow to query, to analyze. You cannot do like proper ATLs with big data, with a lot of small files. So this is an example I just did quickly. So if you had a traditional partitioning based on country, and we have some shipments, all the information will be separated in different partitions, which are the gray boxes. And the idea here is that if you have a data set that is askew, which like most of the real data sets are, then you will end up with a partition that has a lot of data, another one that has very little data, another one has lots of small files. But again, like you always have to choose one column to partition, and then like you end up with not being able to filter efficiently by the other ones. So this is the reason why partitioning is not good for the high cardinality columns, but when you have times the same, because you need to choose date, whatever, and when you have things like the data very skewed. So the answer, it's liquid clustering, and what liquid clustering does, it groups the data by similarity. And by grouping data by similarity, you end up with this shape, which is like you got a single file, which is the gray area, that mixes data from different categories. For instance, in this here, to make a more realistic example on when liquid clustering is effective, it's like instead of having country, let's use liquid clustering on a column that is city. In this city, you end up like having a same file that groups data from different cities. but that they are similar. And in this way, when you go to read the data using any kind of reader, it's totally compatible. And it is a lot more efficient to filter the data because it scans through the commit log and it sees that there is a file that has a min and a max range that is a lot smaller than using partitioning. And yeah, so therefore you get a big speed up because you only need to consider a very small subset of files instead of scanning all the partitions when you are not using the partition key. And this is how you create a table that is using liquid clustering in Databricks. We'll talk about this later, but right now it's only available in Databricks. Yeah, so this is a real example with about 800 gigabytes that I did. The idea is that I selected these 3 columns, which is like a very representative example of all the workloads that I see day to day, where you have like a typical int, an identifier of some sort. It can be an add, it can be whatever timestamp, because you always, like many times, use your data to do historical analysis and so on. You want to know when it can happen, and then a typical categorical, which can have high cardinality. So here what we do is we just use the cluster by clause that already existed in Apache Spark. But right now, so the cluster by already existed, but it was used to reorganize the data inside the Parquet files and so on, and in the same partition. And now with the same semantics, we're able to use liquid clustering instead of the old approach. And yeah, so Delta Lake is so smart then by just saying that it will group the data by similarity using these 3 columns. And the idea is that when you insert the data, if the data set is small, it will already compute the liquid clustering on the right time. So if the data set is smaller than 500 gigabytes, it does the liquid clustering on write. But if the data set is large, like in this case, it is not able to do so at the right time, and you will need to trigger an optimization operation. So in this example, in the end, the optimize took like 48 minutes, which is quite a lot compared to the time they took to write the data. And the idea here is that to optimize and to calculate the liquid clustering, when you write lots of information, it's to reorganize everything in memory, and it's expensive. And because it needs to evaluate the distribution to understand like how to order the data with sorting and so on. So it's a lot slower than actually writing the data. But yeah, this is the benefit that you get. So these are 2 queries, and I made an example like comparing using partitioning and liquid clustering. When you use partitioning, you can see here, yeah, it goes a lot slower, basically by 2 to 3 times slower using partitioning. But when you get to use liquid clustering, you can do a lot of file skipping and read a lot less data. So in the first query, we partition, you had to read 400 gigabytes to solve it. On the second query, Apache Spark is able to solve the same query by just reading 20 gigabytes, which of course makes this huge difference when processing. And all the same, like you end up like considering less files as candidates to access from the object storage to do the computation. And yeah, you get a big speed up. So actually this graph, it's the same query running the same cluster for 5 times consecutive. So you will see like that the first performance on both approaches is lower, and then it improves because I wanted to also understand like how caching affects. Because something that I noticed is that liquid clustering, since it needs to access a lot less data, it can also use caching a lot better on Databricks serverless or Databricks traditional compute, because the amount of useful data fits into memory, local cache, or local disk, or whatever it is. And the first query was filtering on all the columns, and the second one was filtering only on a subset. And if you can see here that because it was using partitioning and the data corresponds to 2 days, the first one was filtering the data on 1 day, so it read half the data in partitioning, while the other one, since we had the data partitioned by date, but the query was not filtering by date, to solve the query had to access everything. But thanks to liquid clustering, we don't need to do this anymore. And this is a very complex graph that will need some context. So I wanted to understand here, like, which is the min-max range of the different packet files after applying liquid clustering. So bear with me. I took basically the column that it's an int, and I computed which is the distance between the minimum value and the maximum value of each packet file in the Delta Lake. Before using liquid clustering with partitioning and with liquid clustering. The idea here, or what you can see, is that after using liquid clustering, the range of the minimum and max values of each packet file, it's a lot smaller. So a lot of files have a smaller range compared to using partitioning. With partitioning, there are a lot of files that have like a bigger range of min-max values on each packet file. What this implies is that when you want to access the data and you have a query that is filtering for a specific value, in partitioning, you will have to consider a lot more files because all of them have wider ranges for the min-max values, while with liquid clustering, the ranges are smaller, and thus you get the speed up that we saw. And what it changes in the end, so the commit log, it doesn't change much. Basically, you end up with having this liquid metadata ID and not much more. So you can see that you are using the liquid clustering because on the ads after the optimize is using liquid metadata ID. And then you will also see the cluster by that includes the keywords that we used before. So the liquid metadata ID, what it does is it helps Databricks or Delta Lake, I'm not sure still yet, to keep track of the properties used in the clustering, in the liquid clustering. Because with the liquid clustering, you can change the keys used to cluster at any time. And therefore, you end up with a different definition of the clustering. And to do that, you don't need to rewrite the full data set or anything. It's incremental. So that's why they have this idea to keep track of the liquid clustering. And this is what is happening underneath when you run the optimize and you want to reorder all the data to have this liquid clustering. It basically does some scanning, it computes some distribution and so on, and by taking a sample, and then it starts to order the data by the different columns used in the clustering, which you can see down there. And yeah, there is not, so in this part, there's not much known because it's something that is private to Databricks. It's not open source yet. The talk doesn't explain like how it works internally and so on. So this is the research that I did until now. I hope I can do more, dig down deeper someday. But liquid clustering has some limitations that there is no liquid clustering in the open source yet. There will be. They are working on the draft. So they are doing the draft now on how this can be implemented in the open source version. It has a limitation on the number of keys that you can use. It's 4, but in general, queries that filter data, you don't tend to use more than 4 regardless, so it's still fine. I guess that this is to avoid that. And you have like many combinations of possible keys, and then you have like amplification of the number of files, but who knows? And then they don't support structured streaming so writing using structured streaming does not cluster the data at the right time. It's not supported yet, but if you use the recent Databricks runtimes or serverless, it works with liquid clustering. And yeah, what I was saying before, it's not 500 megabytes. I think it's 500 gigabytes, which is also the limit of how much data you can write at the time and trigger the liquid clustering at the right time instead of having to run an optimization in the end. So yeah, this is it. That's the reason why we don't have partition anymore. That's why we don't want to say liquid partitioning, because it's a way to replace partitioning or traditional partitioning, and that's why we have now liquid clustering. So, do you have any questions?
Thank you for the presentation, Paul. One quick question. Right now, after your presentation, first question come to my mind is I already have a full of tables, big tables with the old-fashioned partition type. So it's possible to put an alter and add this cluster syntax you have shown us, and then with an optimize and like a translated in this way of partitioning, or has to do?
Yes,
It's possible.
it's possible. But there is a guide on the Databricks website that explains also like the considerations when you want to do so, because you may have lots of data. But yeah, it's possible to do so.
Okay, thank you.
Hey, Paul, thanks for the
Hello.
presentation. All right, so I have two questions for you today. So the first one is, what's the difference between liquid clustering and bucketing in Spark?
Okay. So liquid clustering. So bucketing, it's a way to reorganize the data inside the different partitions by kind of similarity. But in the end, it's a very fixed schema because you end up like having these partitions regardless. So you still partition by a column. While liquid clustering allows you to group data by similarity by all of the columns and not having a strict partitioning, and you don't need like to use partitioning, you need a categorical column that doesn't have high cardinality. But with liquid clustering, you can use whatever you want. Up to a certain limit. So
at any time you will be able to tweak like the clustering columns, just changing the table DDL definition.
yes,
Okay.
you can change them, but I'm not sure like what is the performance there.
Yeah, that's nice. And I also recorded in your slide where you showed some numbers, like some graphs. I would like to go back to that. No, that one. Yeah.
That's
So
right.
what this analysis was about, like it was just about, filtering, running some queries about filtering data.
Yes, so they were
Yeah.
like real BI queries.
Yes, I wanted that clarification because I also want to ask you, I don't know if you performed the test, but some data sets are skewed by definition, as you mentioned. Most of the data sets are already skewed, but when you and as far as I understand, this liquid clustering is like a way of storing data to read them more efficient, right? So how this liquid clustering will help me if I have a skewed data set?
Good question. So the idea here is that when you have a skewed data set, you usually end up with big files and small files. By using liquid clustering is able to split these big files in smaller files, and the smaller files to group them together to have bigger ones. So that way it helps you balance the file size, to unify the file size and don't have like also a very skewed distribution of the size of the files.
So will liquid clustering like pick these files? And well, there are two different things. One is the files, okay, and the other thing is the in-memory partitions. These are two different things. So liquid clustering will like regroup stuff in memory in order to avoid the skewness somehow?
No, so my idea is that when you have a skewed data, you end up with a file that has like many values in the end. Another one is smaller. When you run the optimize command, it will split the big one in two files. And maybe if the column used to cluster it's the same exact, and it will have the min-max that it's the same on both. I will have to consider both of them, but at least it will be smaller, and I can set in separate executors and do the computation if that's where you are going.
Yes, thanks for bringing this out. It's very interesting seeing benchmarks. I would like to see in the future, like what's happening if you perform, for example, a left join operation, because left join also kicks actions. It's a wide transformation. Yep. So it will involve like, shuffle will happen. So, yeah. Thanks.
I was going to say this one was doing a small join also, but.
Other questions?
I got one.
Oh,
What about historical data? Because I mean, historical data usually are partitioned, at least in my experience, by date. No, but somehow it's like there's some columns that might help if they are like grouped some that group in another way, right? Like because they are skewed. Liquid clustering does apply with that, because I mean I guess that optimize will rewrite all my data, and it's something in historical. Probably I don't want that because it's a lot of information. Or does it skip rewriting data because it's previously split it into
So, yeah.
files?
So the idea is that liquid clustering, it will rewrite the data incrementally and decide which parts it is optimal to rewrite or not. And all this logic, it's my guess. So the reason why it's not in the open source, my guess is that all this logic still has not been probably decided how to implement in the open source and what is kept private in Databricks and what not. But yes, it basically will consider the new information that you add.
Okay.
And it will evaluate which are the files that are candidates to be also merged together. But it will not reprocess everything, which is something that used to happen with the previous seat order.
Thank you. More questions? Sorry, the umbrella.
In your case, the order of clustering columns, does it have, is it important? Because normally it's like from low cardinality to the highest cardinality, and you have city is the last one.
As far as I know, no. I still need to evaluate it, to be honest. But there is nothing written in the docs saying that it matters. I need to test different combinations and see if the performance change. But right now, it is what I know.
And does it impact joins in some positive way? For example, if you read one data set clustered and another data set with similar clustering, their join will be faster?
It should, but I have not evaluated this.
Okay.
Like the logic and the theory explains that, yes, it should work faster because you already got the data that needs to match in the same executor and in the similar order and so on. So it should be more efficient to discard the data that it's considered on the join and so on. But I have not evaluated it.
Okay, it would be interesting to know if, for example, the data with the same, let's say, ID and timestamp from two different data sets will be loaded to the same executor or node, at least. So in order to avoid unnecessary shuffle later.
Yes, totally. No, and also in the way that liquid clustering gets done, you also get the information about a certain order of the data. So also Spark could take benefit of knowing which is the order of the data and the distribution and so on, maybe to also speed up these kind of queries.
All right, thanks.
There are no more questions. An applause to Paul. And now Paola, she will tell us about uniform. You got one that? Yes. It's done.
Hello. So hello, my name is Paola and I'm gonna talk about the uniform. So first of all, let's situate ourselves. How much do we know about these open table formats? They have several names. I mean, I've heard them all, like open table formats, lakehouse formats, ACID, log structure formats, but they all aim for the same. Yeah, they are the core of the lakehouse architecture. So basically the lakehouse is mixing the flexibility of the data lake and the efficiency of the data warehouse. And here is a schema of how each component works in the lakehouse architecture. So we have this object storage, our Amazon Web Service S3, Azure, blob storage, and inside this object storage, we store the data in files. But all these files have different formats, such as Parquet, JSON, and CSV. But files from the from themselves do not have an idea of what a table is, of what is the overall schema, how the schema is evolving, and what are the transactions that have been made to these files. So here is where the table formats appear. It's kind of a metadata layer that brings these ACID properties to the lake and enables a lot of applications such as data science, BI, and other apps. So on these open table formats, we have three key players. One is Iceberg, other is Delta Lake, and the other one is Hudi. Both Iceberg and Hudi are donated to the Apache Foundation, and Delta Lake have donated to the Linux one. All of three of them become from great big companies that have feel the need to bring to these data lakes. So they need to scale with the data, but they need to this data to also be efficient to query. So here's a feature comparison of the three of them. At the beginning, I think the difference were much bigger. Like some formats were not having this copy on write and merge on read different strategies. The ZT order weren't implemented for all of them, but right now I think they're coming closer, so everyone has this more or less the same features. What does it change is the implementation. So the critical things are the ACID properties, because without the ACID properties, you will not have any lakehouse at all. And the other part is the column stats and data skipping. They all inhabit in the three of them. But for example, the column stats and the data skipping will not be efficient enough if you don't have, if your implementation on transactional and optimization are different. So on transactions, the three of them supports copy and write and merge on read. Copy and write, it's basically worse for write-intensive applications, because what it does is just copy all the data that you have to update and write it again in different files, because files in object storage are immutable. And merge on read, it's totally the opposite. It's super easy to write because it just tags the rows that has been deleted or updated and writes the new data in another file. But when you're trying to read this data, you have to constantly mapping these deleted rows to the new ones. On optimization, we have Zeta order, right now obsolete for liquid clustering, but Zeta order, basically it groups data by similarity, but when you're trying to do with more than 2 dimensions, it starts to be less efficient. We have compaction too, which is the way when you're creating a lot of small files, it will compact them into a bigger one. And well, for example, in Iceberg, we had this hidden partitioning that it allows to do also partition evolution. And on Delta, we have liquid clustering. On benchmarking, this is like the features, main features, they all have the same, but what are the results? And I have to say, benchmarking, sometimes it's quite tricky and quite difficult, because what do we benchmark? What are the metrics? What are the workloads that we benchmark? It is useful for what I'm trying to implement. It is not. There are many different strategies. For example, copy and write, merge and read. I have to test them all, or I have to test none at all. So for example, the typical benchmark that it's run, it's the TPCDS benchmark that it's for testing your analytical database system. But this benchmark, it's by default an append-only benchmark. So for example, Delta Lake and Apache Iceberg will be better for this, but Hudi, if by default, it's not optimized for event. It's optimized for more mutable workloads, for more updates and observes. But in all the benchmarks, going into TPCDS benchmarks or other workloads in fairly conditions, so everyone tested with the right strategy. What has been shown is that Hudi and Delta are closer in performance, while Iceberg is a little bit one step back. So in general, what sentiment analysis, what people used to say, it's the Delta Lake, it's worth for data lakes with ML, NI, and BI. Like also Databricks is aiming for be the ML and AI enabling platform. Apache Spark is for data warehousing and analytics, basically because a lot of connectors on Iceberg are data warehouses, such as Snowflake. And Apache Hudi is designed by nature for real-time data processing, because even the design of Hudi is different from Iceberg and Delta. It has a part of the data it's written in Arrow, in memory, and other part it's written in the files. So you will always be able to query the latest data right away, while your analytical or historical data are written in files. And again, there's no single right answer on what to choose and why to choose one of them. So remember to run your own test if you're trying to build this application. But this is like the landscape right now. So what is Unifor bringing to this? Basically, it's all in one. Okay, we have these three different formats for the three different use cases. I don't know what to choose. I have to make a copy on each one of them for different use cases that I have. So the Unifor, what it's trying to do is the data remains untouched, one single copy of the data, but the metadata is spread. How does it work? It's pretty straightforward. It's not inventing any and patenting a new algorithm. It's basically that Delta connector writes the Parquet file, so that the data is just still in Parquet file format. Then later commits into the Delta log transaction folder, and then commits the same information to the Iceberg metadata folder, because they all have the same architecture underlying. On to enabling, you just have to go with your Delta. This feature is yet in the open source, not like liquid clustering. This is in the 3.0 Delta Lake. You have to just download your Delta Iceberg package, column mapping enabled. This is, it's enabled by default, I think, right now. But if you have like several old tables, you just alter the properties of your table with the column mapping enabled, and you have to go with Hive Metastore. So this is basically how you use it. You create the table or you alter your table. With these properties, you insert whatever you want, and then you will see in the directory of the data, you will see two different folders for the metadata, one for Delta, other for Iceberg, and the files containing your data. Then how you read it, it's basically if you have a metadata file for Iceberg, all the connectors that are able to read Iceberg will be able to point to this metadata directory and consume the data directly from there. This is like the current status published by Databricks. Of course, on the writing side, it's a little bit less, a little bit worse, just because they have to copy multiple times, just two times the metadata. But on performance reading, as we have seen that the benchmark shows really more slow performance on Iceberg, we improve the way the files are organized with Delta, and the speed up it shows also in the different connectors from Iceberg. This is for putting like an example, like each one will have their own. Before we'll have their own kind of connectors and readers, but now with the uniform we can just really democratize the access to the data, that it was the whole point also to making these open table formats. This is like the current status right now. It only includes Iceberg integration in 3.0. Of course, we have to take into account that this sync between metadata have to be done before any query, any external query. So because if we commit the information on the Delta log, but the Iceberg, it's not yet committed, it might be a point in the time when you make a read on Iceberg that you will not see the whole data written in the table. It does not allow external Iceberg writes, because this will just mess up the whole compatibility. Because if we write only in the metadata of Iceberg, but Delta does not know that new data has been added, you will not be able to read with Delta the the same table. And it does not work yet with deletion vectors. I think it's on the plan, but deletion vectors is actually the feature that enables this merge on read on Delta. And I think Delta and Iceberg have different ways of implementing it. So I think that the delay is because they're trying to build like a standardized way of dealing with deletion rows. And on the plan, it's the Hood integration. It's not yet, I didn't see any news yet, but I think, I mean, it's on the vision. So the intention is to go with all the formats. And with the Delta kernel, I mean, right now, I think it can only be used through Spark, but with the evolution of the Delta kernel is a way of decoupling the actually writing of the files and the metadata and the engine that makes the writes. So when you do that, you enable all the other connectors, writing connectors, to write in this uniform format. So summary, 3 different formats, 3 different use cases, a lot of decision fatigue when you're trying to choose between one of the other. Uniform brings interoperability. Uniform brings a single copy of the data, but it's also bringing like a single data layout. Like it's only allowing to write through Delta, so that might be not like room for other improvements, and maybe too much metadata generation. Some time ago we were talking that, I know it's small data, the log data, but sometimes it's talking that the metadata will be the new big data. So we will see. Thank you, and if you have any questions.
Question? No. No? Yes, one.
Hi, amazing presentation. I have a small project and I'm a researcher about Iceberg. So I feel really interested in your presentation about Uniform. Do you think Uniform in the future have the free files format to provide to any solution, or is it not the moment?
Oh, sorry, can you
For
repeat
example,
again?
I really interested in Iceberg.
Yeah.
But I understand well. Uniform in the future have provide the free different formats,
Yeah.
Delta Lake,
Yeah.
Hudi, and Iceberg, because in this moment the faster or the Iceberg is not the best moment because it's a little more less mature than Delta Lake and Hudi. But in data warehousing or BI is really cool.
Yeah.
But I need a solution in the same place for EI, data warehousing,
Exactly.
and real time. My company or my solution don't need 3 different format, 3 different file systems. So if the uniform in the future is the solution, how many times I need to implement it? What do you think?
Like how many, like if you have to implement it with Iceberg on,
No.
how many times do you have like to change again?
Yes.
Yeah, it's not easy to predict, I think, because it just dropped the feature. So we don't have like too many use case information, but I think it's a way of breaking through the future. I think it's, I mean, if you have to try with one of them and uniforms, if you were interested in Iceberg and uniform supports both Delta and Iceberg, maybe it's worth to take it, to try it right away.
Okay.
Go
Thank
with
you.
uniform.
Okay, thank you for the presentation. This is not that much of a question, but just making sure that I understood correctly. So with this, we will be able to write data in Delta Lake format, and still, for example, let's say Job on Spark, the latest versions have very sweet performance improvements for Iceberg. We could benefit from that even if we have been writing all our data in Delta Lake format.
So maybe I do not understand your question. Like if you if a Spark will have benefits for reading
No, I
from
mean,
Iceberg?
Since 2.4, there are very nice, especially query panel optimizations, especially on joins
Query,
and group buys. And
Yep.
we can still.
Yep, correct. You can still read in Iceberg from wherever you want.
That's
Yeah.
Yeah, thanks.
More questions? Yes.
Hi. Thanks for showing this uniform way of accessing and querying data. I'm interested in the slide that shows Lakehouse core. There's one about Lakehouse core.
House. Okay, the first one. Yep.
Yes. This is super interesting. So, like, I'm wondering, to get benefit from, let's say, Lakehouse architecture. I know, for example, we have worked in places where you have old formats where you separate the warehouse from other places where maybe you only have the BI tools and then the machine learning is separate. You try to do multiple things just to give them everybody access. But like this architecture is super useful. I see the value. My question is around, is there a simple way, like does Uniform abstract everything you have, let's say, in one place so that you can just talk to maybe from data science, BI app straight to the object store through one layer of abstraction? Like, What is the value?
It is. So it's a layer of metadata, layer of abstraction. So it's telling all these connectors, all this BI, all this data science, that these are tables and this is the schema and it's worth for each of them.
Okay. That's good. That's good. The reason I'm asking because I've in the places where people do implement data architecture where you have bronze layer, silver layer, gold layer. It turns out that data science folk or machine learning will say they want to read from maybe raw data to do exploratory. But then the BI tools want to read from, let's say, more clean data, that kind of thing. So it's like,
I think that for the three, raw, silver, and gold, I think it's like you're still gonna have like different tables for different stages of data, but you can have all of them in S3 on the object storage, that it might be more scalable in terms of storage and stuff. Yeah.
The things that we see the difference usually because maybe you are preparing the data with something that works with Delta, like Databricks, and you do the pipeline, but you want to consume with a query engine like Snowflakes or big query, which they only read on Apache Iceberg. So this is basically the common things. You can use the best solution works and way to avoid the copy.
thank you. It's super useful. Like you spend less money if you implement something.
Thank you.
And we got something else. Gustavo prepared a quiz, and we will test you if you listen today. I think there's a prize, right?
Yes, there is a prize for the winner. So get ready. Well, this is the first time that I am doing something like this, so I am not sure it is going to work as I expect. But there is a prize for the winner, so get ready because I believe you are going to you all are going to enjoy the prize. So if everyone is ready.
$14, $15. I think it's the likes. The likes are the people that join.
Yes.
19. Nice. Oh no. Oh no, it's Cesare. Okay.
Well, if you are all ready, we can wait because the price is worth it. For the next meetup. How is going? Everyone ready?
Go.
There are people with the phone. Do you need more time?
Go.
We can wait. We can wait for. Yeah,
People-
perhaps.
We're not pressuring you to no.
Well, I am going to go ahead. So, wow, 33 players. Well, let's do it. Oh, this is the first question.
Everyone has both. Oh, 8 persons weren't listening. Yes, for the first time.
There it goes. Oh. Let's see who was paying attention.
What if there's a draw? Oh,
Well, very well.
got 30 prizes.
Let's see. This one was tricky. But well, the last one. Oh.
That was a tricky question. Nice. One person didn't get it.
Correct.
Was it?
Well, let's see who is the winner.
Ribbit. Ribbit. Oh.
Wow. You are the.
You are
Well,
Ribbit?
we have here the
Oh,
prize
nice.
for you. If you want to come here. We have here the
Es Navidad.
well, here for the next meetup, some of you could be also the winner. So, but here are the gifts, the presents for you. Also, a bottle, socks. Yes. So good for the winter. And here also a cup. And these one are for drinking whatever you want. So
I think I will ask you also for the bag to take it home.
you can use it also.
Perfect. Thank you.
So yeah, there are more things.
Okay.
Let me help you.
Okay.
This
so
is it. Yeah, we can go to the canteen. It's down the hallway, and we can eat pizza and drink whatever we have there. I don't know, but let's see.